Okay, so this is question 13, 14, 15 probably, if I make it that far. It says express the confidence interval, and they've already given us the confidence interval completed, so we don't have all the details, the confidence level, we don't have the best point estimate, which is p hat. We don't have E explicitly, but we have the whole interval. In the form p hat plus or minus E. Now, I'm just going to remind you a little bit about the confidence intervals. Specifically for proportions, since that's the one we're talking about here. So what we are trying to do is we're trying to wrap a numerical net around the population parameter. In this case, it's the population proportion. It could have been the mean, mu, or the standard deviation, sigma, or whatever. And what we do is we first create a best point estimate. Now, p hat is the best point estimate if you're going to use one single value to try to target the population proportion p. So p hat is made up of a sample, x number of successes divided by n, and so on. So you probably remember a little bit about that. Point estimate, again, it's our single best point to estimate the population parameter. P hat would be the best one to estimate p. Okay, so we create the interval by calculating the maximum margin of error, and that's based off of finding this z-score, which is itself based off of knowing the level of significance that we are, the level of confidence that we're going to have, and consequently the level of significance that we're going to allow ourselves. And that's the type 1 error that we divide by 2 for the right critical value. We get the right critical value, the positive z-score, multiply it by square root of p hat, that sample proportion, times q hat over n, and if we don't know p hat or q hat, that's another story, but then we create our interval. Okay, so we're already looking at this number and this number that are netting, they're going around p. So they turn out to be 0.111 and 0.999. We can figure in reverse what those are, because if the whole distance across is going to be one E and another E, then two E's go all the way across the interval. In other words, if we find the average of those two, we can get the middle and we can get p hat. So there's several different approaches to this. This is the approach I'm going to take. I am going to take finding the average of those the average of those limits to get my p hat, and then once I have p hat, which is the center of the constructed interval, it's not the same thing as p, keep in mind, then I can just take this right here and I can subtract that to find out how much the error estimate is. Or I could take this and subtract that to find out how much the error is. It'll be the same, so watch. I'll subtract the lower limit and I get 0.4444. That means that there was one error, maximum margin of error to the left of my best point estimate. Just type it in right now so I can get that done. And that's not going to change. It's going to be the same amount of error to the right, since the constructed confidence interval is going to be plus or minus E. So if I would have done 0.999 and subtracted 0.555, you'll see that I would have had that same error, but it would have been technically determined by subtracting on the other side. So that's just a change of format there. You can write a confidence interval like this, you can write a confidence interval like this, or you can write a confidence interval using our interval notation from algebra. If you took algebra with me, you definitely saw that. You should have seen it in your other classes too. Okay, a genetic experiment with peas resulted in one sample of offspring that consisted of 417 green peas and 161 yellow peas. construct a 95% confidence interval to estimate the percentage of yellow peas. Okay, so what we've got to do is we've got to go through this whole process. We've got to figure this out. Well, we know that our confidence level is 95%. What's nice about that is that's one of the common ones. So we can go to our table here. And if you have a confidence level of 95%, your critical value is 1.96. That's one place you can check it out, or you can go to the review chart, in which case it's second or third page. They've got it over here where it states for a confidence interval, if your confidence level is 95%, critical value will be 1.96. If you're using the normal distribution, which we are, and we know that we are because you see that it's z sub alpha over 2. Okay, so that's going to be 1.96, and then it's going to be multiplied by the square root of p hat times q hat over n. Our p hat, since we're measuring the proportion of green peas, right? Use a confidence interval to estimate the percentage of yellow peas. I'm sorry, yellow peas. Okay, then our x will be 161, and our n will be the sum of those two, 161 plus 417. Okay, I'm going on and on about how to do it by hand, but I'm not going to bother doing it by hand because that's not how I do it on the test. But if once I had that e value, I would add and subtract it from the p hat, which is the 161 divided by 417 plus 161. What I would do is I would probably, assuming I have this calculator with me, I'd probably just get the calculator out and run it here. If I can get that to close. Here you would find it under probably stats, tests, yeah, stat, test, and then go down to single sample proportion prop z interval, because I'm doing a confidence interval, so go down to A. You'd need to have 161, the number of successes, and since we're doing an interval to estimate the yellow peas, that'd be 161. You need to also have n. I think the nice thing about the calculator, if I remember, is you can put 417 plus 161, and it'll just, yeah, nice, add it for you. Then you got to have your confidence level that you're choosing. We're going to have a 95% confidence, and you calculate. So there it is, point, and we're going to do 3 decimals. That works out well. 0.242. And scoot this over. Okay. Given the percentage of offspring yellow peas is not 25%. Oh, what was it, by the way? Oh, right here. Okay, so the nice thing too about the calculator is it's going to calculate p hat for you. The 161 divided by the 578 or whatever that was, 78. It's 28%. So given that the percentage of offspring for yellow peas is not 25%, do the results contradict expectations? Better look at those expectations. Part B was where it said it was expected that 25% of the offspring would be yellow. Okay, 25%. Now, we don't know what the actual population proportion of yellow offsprings are, yellow peas are. We just know that it falls somewhere between this 24 and 31. And 25 does fall in that range, so I wouldn't conclude that that's not true. So let's see. Yes, the confidence interval does not include 25%, so the true proportion could not be. No, I would say no. The confidence interval includes 25%, so the true percentage could easily be 25%. So I would go with that. By the way, StatCrunch for this problem, if you're just trying to stay with that, which is not a bad idea, is done by doing stat proportion stats, one sample, with the summary, because we don't actually have the p's, but we know that 161 of them were yellow, and the sum of the two was 578. We want to do a confidence level 95%, keep the same method, compute. Let's see if we get the same numbers. 0.242, 0.315. Those are the lower and upper limits of the 95% confidence interval. Pretty fast. All these problems you can do with the StatCrunch. A researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes to estimate within 0.04 with a 99% confidence if she uses the previous estimate of 0.32, or if she does not have any prior estimates? Awesome. This is a cool question. I like the ones where you have to reverse the process. So let me go to this. Essentially what she's saying is she knows that she wants this to be within 4 percentage points, right? 0.04, 4 hundredths. And she knows that the confidence level is going to be 99%. So again, that's a common one. We would use a critical value of 2.575. So that's this number here. And then it's broken up into two pieces. One where she's using a previous value of p hat being 32 hundredths, so 32%, which would make this right here, what's that, 68%. But she then has to reverse calculate and determine what n is. Or on the flip side, the second part is, what if she doesn't have any prior estimates to go off of? What would you use for p hat and q hat if you're trying to, you've got the e value, that's 0.04 because that's how strong she wants the tolerance to be. She's got the confidence level, she's decided it's 99%, so that's going to be a score of 2.757. But she doesn't know what, she doesn't have any previous results to put in right here. Well, I'll scroll down actually to the PowerPoint. This is from section 7.2, if you want to go back, where they took that score and they already did the algebra, they've solved for n, and then they make the argument. If you have p hat, you're going to you obviously have q hat by default because they're complements, so you're going to be able to do that. But if you don't have p hat, then you're going to estimate with 0.25. That would be the best product you could get because that would maximize their product. If this one was 0.5 and that one was 0.5, 50-50, right down the middle, that's the maximum product that we could get of 25 hundredths. 5 tenths times 5 tenths. So that's what we're going to do. We're going to do both of these calculations. Let's see, maybe I can actually show. Okay, I can kind of show them one at a time. Right, so n, our minimum sample size, is going to be found by taking 2.575. Remember where I got that. It's from 99% confidence level. The critical value is 2.575. Then you square that, and you multiply, and we're going to use a previous best point estimate of 32%. So you'd have to multiply that by its complement. Should be 68%. And then let's see, it's going to follow the correct order of operations anyway, so I'll just go ahead and hit divide, since this is a scientific calculator. It knows to multiply this, multiply this, multiply that, even though I don't have parentheses. We wanted it to be within 4 points. So you square that E and hit it. So 10,285,000 is the minimum. So, you know, if that would have been 10,285,000.1, then I would make it 10,285.1 for n. So if there was any decimal part, I don't care if the decimal is below 5. Either way, I'm going to round the number up to the next whole integer, but this one already was a whole integer. It seems unusually high because for national surveys we can usually get away with something like 1,500 if they're simply random sampled. Let me try the other one. 2.575 squared multiplied by 25 hundredths divided by oh, see, yeah, this is looking like it makes some more sense to me, because if a national survey can be done with about 1,500 people, what's this thing taking that ridiculous number? I'm going to recalculate the other one. But let me do the demonstration of what I was trying to say about minimum here. If this is the minimum, then even if this wasn't a 6, okay, keep in mind, I'm rounding it up, but even if this was a 4 or a 2 or a 0, 1, I would still round this up to 1188 because that's the smallest it's supposed to be. Now let me recalculate the top one. And I'll do it, you know, I'll do it with a calculator that I know is I could just do it in steps, right? And write down the steps, but I'm just going to be lazy. I guess I could go back later and review the video and see, but maybe I just typed that in wrong or something. So let's get parentheses around this. Guess I don't need any there. That will contain the entire numerator. Okay, that is way more like it. And again, I don't like that these keep coming out to conventionally round to the same numbers as the non-conventional round, but either way I would have rounded up, because 1033 is the minimum, which means I need the next whole integer would be 1034. Okay, I think that's an okay place to stop, so I'll stop right here for the videos. Let's go ahead and check them. See if we got any of these right. Right. What is it saying about that last question? Let me check. 902, huh? And 1037. Okay, so I'm a bit confused because I just paused the video and and I ran it again, not using the table with the common critical values, 2.575 or 2.575, when the confidence level is 99%. This time I actually just used the inverse norm. So I essentially went into the table. I had to split alpha. Alpha's 1%, so I used left area of 99.5%, and I squared that, multiplied by 32%, and then did the complement. Here's q hat, 1 minus 0.32, and then I divided by the margin of error and squared, and I got that number. So I don't know what I was doing on the calculator earlier. I can't stop the video, rewind it, and then re-record it. So I'm just gonna say I must have typed something in wrong. In fact, I will play that entire game again with the one change that instead we're gonna make this 0.5, and then this one also 0.5. That's the best we can do to maximize this amount, and we get the numbers we want. This would have been 903. This would have been 1037. And so you see here that 903 would have been a correct answer there, and 1037. I don't know how I got my 1034 and my 1188, but let me not lead you astray. Whatever I did may have been a mistake. This is definitely what we're trying to do here. And by the way, both of these statements, I think both of them, let me double check, are on your formula sheet to remind you if you get nervous during the test. Right, so if p hat and q hat are unknown, then here's your minimum sample size determination. If p hat and q hat are known, or p hat is known, q hat comes for free because it's the complement of p hat. If they're known, then here's your estimation. And then if you're doing if you're using the information from a confidence interval about the mean, then here's your calculation. So I'll just go ahead and submit those answers as they are. I admit it's been a great day that they are wrong, but I thought I put everything in just nicely. And as I put them in again, I see that they work out the way they're supposed to. I think it's just an accuracy issue though. In fact, let me look at this. You can stop the video anytime you want, but you might miss the point that I'm going to make here. Here's a 99% confidence interval. That means you have a 1% for the critical values on both left and right tails, which means you split that in half and you put 5% on the top. Sorry, not 5%, I mean a half of a percent. And you can put that additional 0 in there if you want. On our common table, it's saying that that is supposed to be 2.575. And I think that's where our issue lies, because when I'm doing it with the calculator, I'm getting more accuracy. I'm getting 2.5758, which would actually make it 2.576. And that is my best guess. Either way, looking above, you can see should have turned out to be 903 and 1037.